Okay, good stuff. So we have not so much time. We have hopefully enough time, but we don't. Well, there's never enough time, right? So let's get to it. As always, my friends, please take note of this particular slide. This slide contains my coordinates, my information, my how you can find me. A little bit about me. My name is Josh Long. I work on the Spring team, as was just amazingly well explained. I am a Kotlin GD or Google developer expert. I'm a Java champion, and of course, I'm a Spring developer advocate. My Twitter is @StarbucksMan. It's my direct messages are wide open. So should you have questions, when ineluctably you have questions, don't hesitate to reach out to me, friends. I'm here for you. I want to talk. I want to engage. I want to help answer those questions if at all possible. I also have an email, and you can feel free to send me email as well. I tend to be a little async. Now, before the pandemic, I would explain to people that the reason I was async was because I would be bouncing around from one city to another. That's not the case anymore. So you might actually find that right now, my mean time to response is actually much improved. And if it's not improved, then I have nothing to offer you except my apologies. But I will do my best. I do try and go through all the email and all the Twitter messages and all that stuff, and just answer the questions if I can. And my superpower is I don't know much, but I do know who knows. And so if ever there's a time where you have a question and I don't know it, which is statistically it's going to be a lot of times, but when that happens, I know who to ask, right? That's the trick. And our team, the Spring team, is nothing if not friendly and passionate about knowledge transfer. So they'll be very quick to respond if I ask them on your behalf. So there's also the Git repository. We're going to talk about RSocket today, friends. There's the Git repository for your own edification, for your own leisure, for your own discretion later on. A little bit about me, Josh Long. I have some training videos. These are on Safari. This is like not the browser, but the technical marketplace. Lots of good stuff there. I've got a book called Cloud Native Java that I wrote 3 years ago, which is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, and Spring Cloud. And of course, I've got my podcast about which Mary very kindly spoke just a few minutes ago, called The Beautiful Podcast, where it's just me, talking to people that are smarter than I am. The bar, admittedly, is quite low, but nonetheless, the people I think you'll find the people that have been on the show are just top-notch, amazing folks. So lots of good stuff there. Despite me, basically, there's a blog that I do every Tuesday called This Week in Spring. It's just a roundup of all the stuff that's fit to reprint in the Spring ecosystem. Every Wednesday, I do a screencast called Spring Tips. I'm on a bit of a hiatus. I take time off between seasons of episodes. There's an interregnum, but we'll kick off our 8th season, I think, coming up. And a lot of episodes actually. There's far more than even reflected in that screenshot there. And of course, I've got a book I just finished, all of 2 weeks ago. Right? It's literally now available on all the markets and everything for purchase. It's not a pre-purchase. It's not a pre-order. It's now real. It's called Reactive Spring, and this book is all about how to build reactive applications in terms of Spring and the larger Spring ecosystem. In that book, we talk about a lot of things, my friends. We talk about reactive programming, the fundamentals, and I'm going to hope that you've got some of that today. We're going to kind of whiz right by a lot of that, today. But reactive fundamentals are one thing. There's also a discussion of how to do testing. There's a discussion of how to do web programming and data access, and how to do integration and orchestration, right? Service orchestration and composition. There's a lot of good stuff there, and really, one of my favorite chapters is the chapter on RSocket, because when I talk about reactive programming in the Spring ecosystem, I'm often doing it in terms of what we can do with existing APIs, with existing technologies like HTTP. Now, HTTP has grown by leaps and bounds, but I would still say, perhaps controversially, that it's not quite the protocol that we deserve for building services. It's a great protocol for building document retrieval systems, right? DRMs, right? But it's not quite what we deserve or what we need for the wide, wonderful, potentially latent, potentially distributed world of microservices. And so when we look at reactive programming, we embrace reactive programming because it gives us an answer to two different questions. The first of which is, how do I build more robust software, right? How do I build software that'll do the right thing in the face of service outages, topology changes, and so on? The second question is how do I make the most efficient use of the system I've got, right? So we're going to take a look at all that, but keep in mind the goal here. The goal is to both increase resource efficiency and reduce the boilerplate code associated with building more reliable, more stable, more responsive systems, more reactive systems. So in order to demonstrate these concepts, friends, we're going to go ahead and go to start.spring.io, and we're just going to build a service, okay? And here, well, friends, I could use 2.4.0 and 3, and there's really some interesting stuff there. One of my favorite things that you get, or that's implied in that release, is that we have even better compatibility with the Spring GraalVM native project, and that project gives you the ability to generate native binaries from your Spring application. So it's not part of Spring Boot, but it works well with Spring Boot, and there's a baseline that's assumed there. Now, I'm not going to spend time sitting here explaining GraalVM. Perhaps the amazing Michael Manella, who I've just understood is going to be on an upcoming CJUG installment. Perhaps he'll speak to that a little bit more. But the idea behind GraalVM is that you have a just-in-time C1 compiler replacement that plugs into any standard OpenJDK that replaces the hotspot just-in-time compiler. The genesis of the project was to see what would happen if people were to build a just-in-time compiler in Java, right? Something that would make the code more accessible, clean up some of the complete spaghetti code that has become the hotspot just-in-time compiler over the last 25 years. And that, I think, has been remarkably successful in of itself, because even as just a just-in-time compiler, it's become obviously provably better. That said, one of the more interesting things, one of the things that has sort of captured people's imagination is what has come when people started using it for a ahead of time compiler. So that is to distinguish it from the idea of a just-in-time compiler, which analyzes your code paths, your frequently accessed code paths, and compiles the frequently accessed code into a native binary. Instead, an ahead of time compiler is just a compiler. It's what we would have just called a compiler before the world started moving to virtual machines and bytecode of some sort instead of machine code, right? So the ahead of time compiler takes your Java classes, turns it into bytecode, and then turns that into machine code all in one fell swoop. It just cuts out that warm-up cycle that we know about. The problem is that Graal, in order to do this work, needs to sort of have some information about your application a priori. It needs to have that information up front. Things like any instances of dynamic reflection, any instances of loading any kind of resource. If you load any kind of JPEG from a jar, that's a thing that Graal needs to know about up front. You can't just do this dynamically anymore because you're no longer in Java. There's no JVM, there's no runtime. And so a lot of the dynamic behavior with which we're familiar from Java no longer is possible. Things like reflection become very difficult. Generating classes and loading them into the class loader, very difficult. So lots of things that on which you depend in order to make the work easier, well, that becomes more difficult in the context of a Graal application. So that's what the Spring GraalVM native project is designed to solve. And while I will leave you to my 2 Spring Tips videos or the blogs that we've got for details, suffice it to say, the results are quite impressive. So here's a JPA application that's got Spring Data JPA, which includes, it in turn includes Hibernate, and the application also uses Apache Tomcat. So, you know, pretty stock standard bread and butter kind of stuff, right? Nothing phenomenal there. And where did I put that? Target native, there it goes. This application, what's just happened there? There we go. There we go. So there's the application, right? This application, when I start it up, it takes 0.18 seconds, so 18/100ths or 18% of a second to start up. Localhost customers, there's my data, right? Got some records there, talking to an embedded H2 database. Oh, by the way, that also boots up an embedded database. So it's got an embedded SQL data store, it's got a web server, stock standard SQL data store, and my Hibernate code. Okay, so not bad. And if I go back to here, I've just killed the process, so of course that's gone. Now, if I go to the MongoDB instance, right, CD MongoDB, this is, again, not reactive, just stock standard stuff. So target native image, and then I can run this, MongoDB. And refresh. There's the data. Hit Control C. It's gone, right? I didn't count that one. There you go. That one took. Where'd the time go? 1/10 of a second, basically, to load that. Okay, good. So that's working. And then, of course, there's the reactive edition. Now, the reactive code you're going to find is much more resource efficient, even as just a regular JVM binary. So it's got a leg up on the competition out of the gate. Needless to say, let's see, Control C. What's that about? You'll find that these numbers are much faster on Linux, but they sometimes, I think Mac OS requires them to do some sort of permissions check or something. So 0.098, so it's less than 1/10 of a second before this application's up and running. And then Control C, please. There we go. There we go. So you can see it's really, really, really fast, right? 0.096, etc. Okay, so that's one thing that I would encourage you to investigate in Spring Boot 2.4.3. But for our purposes, as everything that we're going to look at tonight, is that true? Almost everything we're going to look at tonight is GA, then it doesn't all that much matter what version you use. And the one thing I think that we're going to look at that isn't yet GA, as much as it hurts me to say it, it's easily ignored. So that's fine. So we're going to build a new service, and we're going to use the latest and greatest version of Java. What do I have running here? I have Java minus version 15. Oh, that's awkward. We should update this. It should be 15. But in the meantime, we can run Java 14 or 11. I'll just do 14. Actually, 11. That's fine. Actually, you can use 8. Everything I'm going to show you tonight requires nothing newer than 8 in order to do its work. So that's fine. We're going to build a new service. We're going to call it service. We're going to bring in some dependencies here. So we're going to bring in the RSocket support. We're going to bring in Lombok, and we're going to bring in security. And I think I'm happy with those selections, those dependencies, those bits. That said, I encourage you to pursue the larger catalog of things, because we have great support for NoSQL, reactive NoSQL with MongoDB, Neo4j, Cassandra, what else? Redis, just all sorts of stuff. I'm sure I'm missing some there, or Couchbase, right? All sorts of good stuff there. We also have support for reactive SQL with our R2DBC abstraction. R2DBC is the reactive relational database connectivity abstraction. It provides a core reactive SPI on top of which we have started the project with some initial drivers that have since mostly been donated to the ecosystem. That's a great way to connect to a SQL data store as well. What else do we need? I think we're happy. I'm happy with that. So, RSocket, security, Lombok. Seems like it'll be enough. Let's do that. We'll hit generate. Okay, so downloads. UAO service.zip. I'm going to open this up in my IDE. I'll adjust the fonts upward here. You may have noticed that I'm presenting on my 34-inch monitor, so it's sort of, you're going to hear my fans rearing to take off later. I'm going to have to hold this laptop down. I'll have to steady it, to make sure that the computer doesn't take off or burst into flames. Okay, let's see. Font. Okay, 22, 24. Can you all see that, I hope? Unless you can't see that. Oh, yeah? It's a little small? Okay, 20.
It's small. Yeah.
How about that? 26?
26, yeah.
I'm not hearing a Boolean. Yes, so what about 28?
Looks good.
Okay.
Yeah, I think it's, but yeah.
You let me know. You saw how easy it is to fix. I'd hate for this to be, if it's going to be incomprehensible, let it be because it's my normal level of incomprehensibility that does it, not because the font is too small, right? Okay, so application, here's my public static void main, and it's just a brand new Spring Boot application, right, friends? So it's not a big deal, just a regular Spring Boot application, and I'm going to use it to write reactive code. Now, before we get too far down the line with RSocket, we need to sort of kind of appreciate reactive programming, right? And again, I've already explained that reactive programming gives us the ability to to do normal things, right? We have parity. We haven't given anything up by using reactive APIs. Quite the contrary, actually. What you'll find is that amortized over all the possible applications of reactive APIs, you're going to find that the learning curve is actually much less by using reactive APIs, right? And the lines of code is actually much less. So you get the most resource efficient code and you get a much simpler API rather than having to learn, JMS and Kafka and RabbitMQ and threads and WebSockets and server-side events and HTTP application JSON, rather than having 1,000 different ways to express all those different APIs that are all basically answering the same question, which is, given a request, give me data at some point in the future, rather than having those different APIs. Here, you just have to learn the reactive APIs. And if you learn that, then suddenly all those other things are now you can map to all of those, okay? It's just a matter of plugging in a Reactive Streams publisher. So let's talk about that. Let's say I wanted to do, I'm going to create a class here, listener, okay? And in this class, I'm going to create a listener. I'm going to create a thing that's going to be started when the application starts up. And in this class, I'm just going to begin processing when the application starts up. And what I want to do is, maybe I want to have a reactive stream of data. Well, and when I say reactive streams, I'm talking about two particular types, right? I've got one type called a flux, right? And a flux extends publisher, right? Publisher is a type from the org reactive streams package. Publisher publishes data asynchronously out of band to a subscriber. The subscriber then consumes the data, but when it first subscribes to the publisher, it is given a subscription. This subscription is super important. It's this subscription that allows the subscriber to say, hey, I would like more data or less data, please. So it can use it to say, I want to only have 10 more records, right? So imagine you're a consumer and you don't want to be overwhelmed. Well, that's the whole conceit of this API, is to say, I want to control the rate of consumption. I want to control the speed at which I consume that data. And then similarly, if I don't want any more data, I can cancel that stream, right? I can say, no more, thank you. So if I say request 10, I'll never get more than 10 records, and I might get all 10 in the next second, or I might get all 10 in the next year. But the point is, I won't get more than 10. That's the important bit, right? If I want more than 10, I have to request another 10 or another 1 or another 5. It doesn't have to be the same number, right? So you control the rate at which you consume the record based on your ability to do so, your speed, your cadence, your uptime, your availability, right? And finally, if you find that even that is too overwhelming and you just simply can't be bothered to try and process the rest, or worse, you just don't want to process the rest because you've got no need for it anymore, you can cancel. You can say, I am no longer interested in that data. So you've got a publisher which publishes data to a subscriber. When the subscriber subscribes, it's given a subscription, and it uses that to request data. As the data arrives, it arrives in the onNext method. If there are errors, when ineluctably in the context of a distributed system there are errors, they arrive in the onError method. And finally, when something is done being processed, the onComplete method is called. Okay, so that's the basic breakdown. Now that's three very simple types of the org reactive streams package. This package is a joint effort. It represents a joint effort between the Spring team, between the Netflix RxJava team, between the Lightbend Akka streams and Akka teams. At the time they were called TypeSafe, so either way, awesome folks, and between the Eclipse Foundation's Vertex teams, right? So lots of really amazing stuff that went into just these 4 simple interfaces. The fourth of which, by the way, is called a processor. So you've got a processor, which is a source and a sink. It's a producer and a consumer, a publisher and a subscriber, and that's it. That's the entire reactive stream specification. You can see it's fairly Spartan. So like I said, we have 2 specializations from Reactor, not the reactive streams package of this type, but from the Spring team's Reactor library. This project provides 2 specializations, the first of which is Flux, which produces 0 to n records, and the second of which is a Mono. A Mono produces 0 or 1 record. And that's it. These are both publishers, ultimately, but they have lots and lots and lots of operators, things like map and flat map and wrap and filter and all that stuff. And the benefit of those APIs is they give you really convenient operators to do all sorts of common data things. So let's suppose I wanted to create a reactive stream that had some names, right? Just some names in it, right? Mary, good, Michael, good. Madura. These are all just people, okay? and they're names. And so now I've got a reactive stream full of names. And let's say I wanted to, and again, this is a publisher, right? It's also a publisher. But those types, by the way, are those reactive stream types have become so ubiquitous, so common, so naturally useful that they've since been incorporated into the JDK proper as of Java 9. So again, we're just about to, we can now use Java 15 in a GA context. And so when I say Java 9, I'm talking about 6 releases ago, friends. That's a long time, right? That's, what is that, 3 years? Every 6 months? So yeah, 3 years. That's a long time that this class has been available. And this type is it's an outer type, and it contains inner types: processor, subscription, subscriber, and publisher. So again, a lot of times you might use the org reactive streams API if for whatever reason your code is coupled with Java 8 for the time being, then sure, just use that. But interchangeably, you could also use Java 9, and if you're using Java 9, a lot of APIs will give you a reactive streams type, and you can adapt it back and forth to a flow type, a Java util concurrent flow type, okay? Now I've got a reactive stream, I've got a flux, and this flux is just some names. Now if I want to visit those names, I can say names.map. Let's say I want to turn them into uppercase, okay? So here I've got uppercase names, right? Whoops, whoa, okay, up, okay? So there's my uppercase names. Now, again, all I've done is I've built a little pipeline, and on each step I've used lambdas to build up and iterate on this pipeline. Now, nothing is going to happen. If I ran this code as is, nothing would happen. I would have to actually subscribe. So you normally subscribe because otherwise this API is inert. Nothing will happen, okay? Now, where the real power comes in when you talk about reactive APIs is that behind the scenes, there's no guarantees, there's no discussion of on what thread this code will execute. There's nothing that says that this thread needs to execute on the same thread as this one. So indeed, the runtime might decide to run this particular thing, which is just evaluating simple string literals on one thread, and then do the mapping on another thread, right, as the system has the capacity to do so. And the benefit of that is that we can do some really amazing things if we understand that the threading behind the scenes is not something we have to worry about. So, okay, let's talk about that, right? Let's say I wanted to do, where you really get some benefits from reactive APIs is when it comes to service orchestration and composition, because this is the place where you would most naturally confront threaded code in a non-reactive world. So let's suppose now, moving beyond our little trivial example here of a reactive stream that we can operate on and so on. By the way, you can also chain these things together. I didn't mean to string them like that, one after the other, right? There's no reason they couldn't be chained together, right? Let's suppose that I actually had 2 different APIs. And again, here, all I'm doing is I'm creating a little stream that has some strings in memory. But it's very common in the reactive world that you get APIs, you get reactive streams from something else, right? So let's say you have a name service, okay? And so here, I'll leave it to you to, we'll see later, but suffice it to say, you can get a reactive stream just like this from your SQL database. You could get it from a network call, an HTTP call, right? So it doesn't really matter where this stream came from. Let's suppose I have a stream of names, and I also have another stream of integers, right? Or maybe it's, ages or something like that, or maybe it's whatever. It doesn't matter, right? It's just some other bit of correlated data. So what's it? IDs. I don't know, just some other bit of information. A more natural example might be I have a product. I have an order from a e-commerce engine, and then I have different orders, and then for each order I have an associated profile. So I need to get the order details and the profile at the same time, one by one. So I can say select all from orders where order ID in orders, and then order by order, and then select all from profiles where, the profile is in the list of the profile contains the order that was just passed in, right? So you'd get you'd order them both by the order ID, and you'd get the same results in sequence. And so now what I want to do is I want to join them up, right? And so what I'm doing is I'm making 2 network calls. Okay, so let's just say return flux.just 1, 2, 3, 4. Okay, so whatever, we're going to say that these orders are just completely random, right? I've got orders there, and I've got IDs. Now what I want to do is I want to say, okay, given these things, IDs. I've got 2 reactive streams, but remember, nothing has happened yet because we haven't subscribed to either one of them. So if we subscribe, remember this will happen on a separate thread. So if we subscribe right now, even though I subscribed here, even if this takes an hour, this won't block, the subscribe won't block this from beginning. And that disconnect between when you assemble the pipeline and when you actually see the results of the pipeline, that assembly time versus execution time discrepancy is part of the power of reactive streams. It gives you the ability to rewire, reconfigure how the actual pipeline looks before the pipeline actually has water flowing through it, right? So we're creating a pipeline, but we haven't turned on the faucet yet. And so that gives us time to intervene before that actual water starts flowing through it. So for example, let's say I wanted to watch both of these. I want to follow both of these reactive streams, and as they come back, I want to join them together. Okay, so here I can say flux.zip, right? And here I'm saying names from service. Oh, sorry, I'll just use names and IDs. And now I'm doing kind of a scatter-gather kind of thing here. I'm doing a join across 2 different microservices, and what I get from that is a new reactive stream, but this reactive stream has a tuple, and the tuple has a T1 and a T2. T1 is a string and T2 is an integer. So it'll take one from the left stream, one from the right stream, and it'll keep emitting new tuples containing both of them, right? So this is very convenient if you're trying to do correlation. Very, very, very powerful technique, and yet you didn't see a single executor, a single runnable, a single thread, a single phaser, etc. here, right? This is a very natural thing to do. Okay, let's suppose that the problem that we have, oh, there's messages. Let's suppose that let's suppose that there's more than one host from which I would like to get this data for the names, right? So let's say that I'm going to pass in a host, right? And I want to guarantee that I get the result back in time, okay? So again, I'm not using this host parameter, but just imagine I'm making a network call to an HTTP service, and I'm getting the results back. I want to make sure that I get the fastest response from any of the available services. So there might be 5 different instances of the service, and I want to make sure, in order to meet my SLA, that my response comes back as fast as possible. So that if it is failing, then that's okay, right? Well, I can use this I can say, okay, host 2, host 1, host 2, host 3. Right? So now I've got 3 different reactive streams, and I want to tell the API, hey reactor, give me the first one to emit a value. Okay? So this is kind of like select, if you've ever used the POSIX API, or actually it's kind of like selectors API, right? So here I'm saying, okay, flux.first, host 1, host 2, host 3. Right? So there we go. There's our reactive stream, and I'm getting the fastest one back, and it's going to automatically apply back pressure. It's going to automatically cancel the other 2 streams. So that even though they may have already started producing data, they're not going to waste time producing data that we aren't going to use. They may have started, but they're not going to continue going. So if we made a particularly expensive network call with millions or billions or whatever of records, then we can at least rest easy knowing that we're not wasting as much as if we had no other way to do this. We can signal that we want to cancel that stream, right? And this will just do it for us automatically. So the first one, the stream that we get back, is the first of the different hosts to produce a response, right? So this is how you guarantee you can meet an SLA, right? This is much more useful than, for example, doing a retry, because retry requires you to wait a certain amount of time, exhaust that timeout, and then retry again. Well, hopefully you're not chewing into your SLA window, right? With this, you're saying, hey, I'm going to just assume one of these will get back to me within a reasonable amount of time. And so now the pressure is less on the downstream service to respond, because even if it does something else well, and I still won't even have gotten past the initial SLA, right? But that said, maybe you do want to do a retry. Well, reactive APIs have all sorts of interesting operators. I can do a retry. I can say I want to retry 10 times, or I want to do a retry.backoff, right? 10 duration of second one. So you can do that. You can also say on error resume. So when there's an exception of, illegal argument, whatever, doesn't matter, then I want to do something. I want to provide a stream that I provide when a particular exception happens, right? So I can control how that fails, right? Eek. And so on, right? So you can do on air. You can also do timeouts if you really want to, right? Obviously, you can do a timeout as well. I'm just saying that with these APIs, you can do a lot of things that would have required a lot of threaded code in the old world without having to worry about that. And so, that said, what else do we need, right? Like, what can we do to improve this? Well, here's the issue, friends. Here's the issue. The issue is that I'm just doing these local in-memory reactive streams on my local machine, and I'm leaving it to your imagination how I source data from another endpoint, like an HTTP microservice. And obviously, HTTP gets the job done, right? We've all, it's been used in production. Obviously, it's a very natural thing to do with Spring is to deploy something into production with HTTP and so on. That said, I wonder if we couldn't do better. So there's some issues with HTTP. One is that it's especially I'm talking about HTTP 1.0 here, unless otherwise noted. HTTP 1.0 is porous, it's text. So it's, even binary data has to be communicated as base64 encoded text, and then it has to be unencoded on the other side, which is not great, right? It's request response centric, right? You make a request, you get a response. Nothing else. It's not possible to do fire and forget. It's not possible just to say, here's some data, and then I'm going to ignore the response. I don't care about the response at all, right? Which is very common when you have, a system where you're broadcasting information, but you don't care about acknowledging the response. And it could be something where a little bit of lossiness is fine, right? For example, streaming video. You go through a tunnel. You may have missed a few frames, but the user isn't going to want to they may have already advanced beyond the section where the frames were dropped. So they're not going to want to stop the video feed and say, hey, hold on, we're going to go back and get those 2 missed frames. It doesn't matter to them. They've already moved on. The damage is already done, right? Presumably they already saw enough to understand what was happening. So that's one issue, right? The lack of flexible interaction models. Another issue is that, like I said, it's text for everything. It's porous. So HTTP 2 improves upon this. It's binary, which is better, but still not great for most people if they're using HTTP 1.0. HTTP is also a fairly simple protocol, right? It has headers, which is good, but since it doesn't support bi-directional communication, since it doesn't support fire and forget, since it doesn't support these common things, people use WebSockets to get around some of that. Well, even there we get some issues, right? WebSockets don't have headers. So without headers, you have no way of communicating out-of-band information like a service token, right? Something you need for security. Security, last I checked, good thing, useful, good to have. So it'd be nice if we could do that, right? You can authenticate a WebSocket client when the connection, the WebSocket stream is first established, but that's not the same as actually authenticating on the wire, etc. Okay? So lots of different things here that make HTTP less than ideal. Now, HTTP 2.0 improves upon some of that, and Google took that a step further, and they built something called gRPC. I like gRPC. It's just that it's not reactive, first of all, on the wire. It's asynchronous. And then second of all, it requires Google protocol buffs. So if you have any other kind of encoding, well, you're kind of in a pickle there, aren't you? So even there, I think we can do better. So one option that I think is particularly promising is RSocket, and that's what we're going to talk about today. RSocket is a protocol that's sourced from Facebook. It's a protocol that actually was sourced from people working at Netflix, who then went on to Facebook, and so the project kind of went with them. And the project is designed to sort of solve a lot of the limitations of gRPC, of HTTP 2 and HTTP 1.0. It is a stateful connection, so when you first connect, one socket stays connected to the other, and they stay connected for the life of the Java applications, right, or the Go applications. It's a wire protocol. That's the other thing. So it doesn't matter what language you're using. You can use the protocol from anything so long as there's a client, and there's already ample clients for Java, for Go, for C++, for JavaScript, for whatever, right? So people use it from Android, from C++ code, from iOS, from the server side, from the JVM, and so on. The client for RSocket, by the by, for Java is written on top of Reactor. So Reactor, you've already seen Reactor, right? Flux is a Reactor type. It comes from Project Reactor. So all these things all these things make RSocket really interesting for developers who are working on the server side, right? And for the Spring team, we looked at that and said, oh, it's a stateful connection, stateful-oriented connection protocol. Okay, check, good. It is bidirectional, so once either side is connected with the other side can initiate the discussion. They can send data or request data or whatever at any time, at any point, regardless of who connected first, right? So both sides can connect and they can do absolutely nothing, or one side can send data to the other, or both sides can send data at the same time. So there's no real sense of, or no real concept of client service within the protocol itself. Now, that's not to say that you in the arrangement of your software won't have a notion of a client or a service, right? The thing that's deployed in your data center might be the service to the clients that are making the connection, but those clients may want to talk to you, and they may want to send data to you, or they may want to ask, or they may answer questions from you, right? And in which case they become services as well. So they're, in the context of the RSocket world, we say requester, responder, and either side can be either thing at any time. They also support 4 different exchange request response, fire and forget, one message in, one message out, so request response. They support one message in, a stream of values out, right? That's called request stream. And then they also support something called channel, which is a stream of values in and a stream of values out, right? So you might be sending ongoing telemetry, in which case they're sending ongoing acknowledgements of that telemetry or whatever, right? So lots of different use cases that are well supported there, and this kind of makes it, it makes it so that you can do some amazing things. One of the things that I think is most impressive about it is its operationability, right? Operationalizability. It's built for production. So the people working on it realize that these are going to be services that are going to be working at peak performance. They're going to be demanded quite a bit. And if everything goes right, since they're reactive, they're natively reactive on the wire. And by that I mean that they understand this concept of back pressure, right? Since they're natively reactive on the wire, hopefully they're going to be deluged. Hopefully they're going to be pegging your CPUs at 100%, because there's never going to be any idle time associated with waiting for the next thread to become available, right? Whenever something is done, they're going to do the work and they're going to jump off the thread and then return that thread to the thread pool while waiting for the next byte to arrive from some request that's in flight or whatever, right? So because very busy, it became important for there to be a way for the service to communicate its health, its state, its uptime, right? And so if you've ever used Spring Boot, then you probably know about the Spring Boot actuator. The actuator are a set of management endpoints, and you can add them to your build just by going to start.spring.io and choosing actuator, or indeed you could just add them to your build right now. Just say Spring Boot starter actuator, and then Bob's your uncle, you've got a new build, okay? Now, I have you've got a set of new endpoints, right? And these endpoints give you information about the state of your service, the health, the uptime, metrics about the service, etc. Things that you can use, or a smart operator can use, to decide how to interact with your service. I think that's pretty useful. That said, that's a convention in the Spring Boot ecosystem. There's nothing in the HTTP protocol itself that says I must export that information. I must make that accessible to clients so that they can decide whether I'm too busy to handle their request or not, right? And so what we have is in RSocket a protocol frame, a message frame designed to speak or designed to articulate this information, the state, the health of the service itself, right? Pretty cool. What else is there? There's also, and if you think about it, that's actually kind of a reverse back pressure, right? So one back pressure is where you say, I want to subscribe and request only 10 records, right? In this case, the client of the thing that's producing the data, the consumer of the data, is pushing back again. But the producer, by virtue of this metadata frame, can also say, hey, I'm too busy. I can't handle this right now. Please don't ask, right? So there's bi-directional sort of back pressure in that way. The other thing is we get true session resumption here. Now think about what happens when you have an HTTP endpoint. when you have a reactive HTTP service, and the reactive HTTP service streams data back to the client gets the data, and if it no longer is interested in it, oh, that's a good question. Don't let me forget to answer some of these questions at the end. There's some really good ones. When the client gets the data, when it consumes the data, and it decides it's no longer interested in the data, or for whatever reason it needs to disconnect, it disconnects from the socket, and the server, the best that a reactive HTTP service such as ours, our Spring Web Flux, our reactive HTTP web framework, the best that something like that can do is to perceive the socket disconnect and apply back pressure, transitive back pressure, to cancel everything that has been that has started streaming the responses back to that client. That way, we're not wasting any more time. That's it though. That's one-time back pressure. That's all you can do. You can cancel, right, for HTTP. You can't really say, I want to request 10 more records, and then an hour later request another 10 records, because there's no context there. You can, you can send a session or something, or like that, so you can recreate the idea of state, but there's nothing intrinsic in the protocol itself. Well, RSocket understands where you are relative to a stream. It's built in, right? So I can actually have an RSocket client running in Android, start scrolling through, my feed of information in some sort of Android RSocket app or client, and then as I go through the tunnel, my signal disconnects. That's fine. When I get back out, I'm still connected. I can reestablish the connection, and I can say I want to resume from the offset that I was at before. I don't have to reestablish or reload the entire stream. So this is all really interesting because I have RSocket. So that's what we're going to talk about today, my friends, is how to use RSocket to build more stable services and take advantage of the good engineering work being done by the Spring team, by Facebook, by Netflix, by Alibaba, right? So that's the other thing, is RSocket is the fledgling project of the Reactive Foundation. The Reactive Foundation is jointly developed or jointly originated by, among others, Spring team, by Alibaba, by Facebook, by just Netify. I mean, just lots of really interesting organizations. So, a lot of people are working on it. What I want to do is I want to build an RSocket service, okay, with Spring. So this part's easy, right? Is my keyboard? Okay, my keyboard seems happy. This part's easy. What we're going to do is we're going to build a service called Greetings RSocket. What am I doing? RSocket controller. Okay, and this is just going to be a Spring controller. And I'm going to create an endpoint here called Greetings. And the Greetings endpoint is going to return a stream of Greetings response given a request, a Greetings request, like so. Okay, so publisher of Greetings response, Greetings request. So there's the reactive stream, okay? Now, what I want to do is I want to just generate an infinite stream of responses given a request. So I'll say this is a DTO. It's going to have these various things that we need here: getters, setters, toString, equals, hashcode, etc. Okay, and I'll paste that in there. Good. And the request is going to have a name. Goody. And I'll have a response, or a message, I suppose, in the response. Okay. Now, given that, we're going to say return flux.fromStream, stream.generate new supplier. So the supplier is just going to produce a new response it's going to produce a new response at infinite capacity, at infinite speed. So we're not going to want that, because otherwise our demo would be hard to follow, right? Because the output would just scroll down to the floor and out the door. So what I want to do is I want to stagger the results a little bit here. Let's make that a little larger. Okay, goodbye, good. Okay, so there's my preliminary stream. And we can clean this up a bit first. So replace that with a lambda, very good. And we can say, okay, delay elements, duration of seconds, 1 second. So I'm going to delay each one by 1 second. And I can do this because I have that scheduler behind the scenes. The very same thing that allows us to move work from one thread to another, that's in play here. That's what's allowing us to introduce time as a dimension of my API. Okay, so now I've got this greetings controller. You know what? I might even want to extract that out into a service, right? Greetings service, and of course this could be a reactive stream coming from a chat or a, anything that requires liveliness, you'll find is a very nice fit for a reactive APIs, right? So stock tickers, chat, telepresence, notifications, telemetry, all that kind of stuff. So let's see, require object control. Do I have Lumbach? There we are. So I'll say greeting service.greet request. Okay, so there's my controller. Now, I want to export this. I want to make it available or accessible as a service to which other RSocket clients can connect. I'll go to my application properties, and here I'm going to specify an RSocket port 8888. Okay, so that's I have to specify that port in order to tell Spring Boot to automatically start up the RSocket service. So actually, we can just run this here like so. So we have now our service up and running. So what else? We want to talk to it. Now there's a number of ways we can talk to it. One is to use the RSC client. So RSC is kind of like curl for RSocket endpoints, right? So what I want to do is I want to make a request that sends in a single value, right? A single value, and gets back an infinite stream of values here. So that's a stream response, right? So I'll say stream. The route that I'm going to be calling is greetings, and the endpoint is TCP localhost 8888. Whoops, seems unhappy. Oh, I've got security. I forgot to disable the Spring security bits. We'll get back to that in just a second. So, goodbye to you. You can see that was slowing actually, the Spring security stuff, there's a lot of stuff there. There's messaging, Spring security, etc. So that's adding some overhead to my startup time. Let's see what I get if I remove all that. I didn't mean to imply that you should remove security for performance benefits, but I'm just saying raw RSocket is really fast. Okay, so we'll take two. What's wrong now? Oh, I forgot to send data in. So I need to send data in. So I'll say -d. Okay. Name. And the name will be CJUG. Alrighty, there's the data that's coming back from my RSocket service, my reactive RSocket service. And in fact, I can do log and debug. And when I do that, I get the methods that are being called in Reactor on next, etc. And I get the binary data, the dump of the data over the wire. How cool is that, huh? So okay, so now we've got basic ability to talk to an RSocket service. I like that. I like that a lot, right? That's a very interesting way to be able to talk to RSocket service. There's a lot of other things you can do with RSocket, though. There's a lot of different ways to talk to it. So one of my favorite ways that is kind of, I think it's I didn't realize how much people would appreciate this opportunity or this option, and I started showing it to people, and they're like, oh, that solves a lot of my problems. So I'm going to show it to you. I don't know if you're going to need this, but hey, who knows? You can also use Spring integration. So Spring integration is what is Spring integration? Spring integration is a messaging framework, right? So go down to here, UAO integration.zip. Do I have some spare Java processes running? Okay. I might have something running somewhere. Seems fine. Okay. Okay, so we have now our integration application. Now, Spring Integration is a messaging technology. It's a framework for doing enterprise application integration in the spirit of Bobby Hope's and Gregor Hope's and Bobby Wolf's amazing book, Enterprise Application Integration. And it's a messaging technology, so it doesn't care about reactive per se. It cares about integration. And as we move ever forward in time, the surface area of things that need to be integrated with other things grows bigger and bigger. So these APIs, reactive APIs are one more thing you can integrate with, and you can use Spring integration to take the old world APIs and glue them with the new world APIs. It can be, well, an integration hub. So I'm going to build a simple integration flow here, and we're going to just build a flow that looks at data that's coming from the file system. Okay, so Spring integration can take data that originates from the outside world, turn it into a Spring framework message, and then allow you to respond to that message and do something with it, route it, split it, aggregate it, enrich it, transform it, whatever, and then send it out again to the outside world. So source sync, right? Inbound, outbound. And you say that when you take the data from the outside world, you're adapting the inbound message, or you're adapting the outbound message. You're adapting the thing that you're sending to the outside world. If it's unidirectional, then when a message comes in at one time, one way, that's called an inbound adapter. But when a message comes in and you produce a response, that's called an inbound gateway. Ditto for something that you send out. You send a request to another service and you get the response, that's called an outbound gateway. So what I'm going to do here is I'm going to use this gateway here. I'll say, well, first I need to bring in the Spring integration support for files and for RSocket. So I'm going to bring in the particular dependencies there. Spring integration file, okay, and RSocket. Goody. Okay, so there's obviously supporting RSocket and file systems, and I'll build a file inbound adapter. I'll say files dot inbound adapter, and here I'm going to assume that I've got a directory full of files that I want to process. So I'll say system, we can go a step further actually, we can just inject it. So we'll say user.home desktop in, and it's going to be a file on the file system. Okay, good. So we're going to say in, and we want this directory to be created if it doesn't already exist. Voila. Okay, there's my file inbound adapter. And so I'm going to say I want to read from that directory. So whenever there's a new directory, and I'm going to pull that directory every second. And I'll say pmc.puller fixed rate 1000. Whenever there's a new file in that thing, produce a message. I'm going to take that message. I'm going to take that file.class, and I'm going to transform it. And I can write my own transformer, like so, file to a string or an object or whatever. I can parameterize it, certainly. But it turns out, because Spring integration is kind of like the ultimate enterprise architect's Lego box, there's already lots of stuff included out of the box. So file to string transformer is already there, right? And then now that I've got a string, I want to take the string and I want to, trim it a little bit. So I'll say str.trim, and voila. Okay, there's this as well. Now, when I have a string, what I want to do is I'm going to take that string, I'm going to assume that's a name, okay? I'm going to assume that's a name, so I'm going to transform this name into a greetings request. We've got our RSocket service over here. I stopped it, killed it, goodbye. I'm going to copy these DTO types. We'll paste that here. Okay, and what I'm going to do is I'm going to create a new greetings request with a name in it. The issue here, object. Oh, it's right, it doesn't know that it's a string. Goody. And then for each one of those, I want to call handle. I want to call the RSocket service. I'm going to send in the name to the RSocket service. So RSocket gateway, okay? RSocket dot outbound gateway, okay? And the outbound gateway is going to need the route, which is the greetings endpoint, and it's going to need some information, like what kind of interaction are we expecting to do? Well, as you know, we have 4 different choices here. So it's going to be a request stream, not fire and forget, although it could be. We're going to need to provide a client RSocket connector, so we'll define a bean of that type here, client RSocket connector, RSocket kind of thing, client RSocket connector. Like so. And it'll be var crc, not car. New client RSocket connector. Host will be localhost. Port will be 8888. And then we need to inject the RSocket strategies, which is an object that Spring creates behind the scenes. Spring Boot auto configuration creates it for you. You don't need to worry about it, but it's what you would use to override things like encoding. How do you encode the data? Things like that. So if you want to teach an object about all the defaults that are being used in your RSocket configuration, give it a pointer to your RSocket strategies, and that'll get you to where you want to go. Okay, so here I'm going to say C dot client RSocket connector, this thing, CRC dot, and then finally we expect this stream response to be a greetings response. And I think that's it. I think that's everything. So that's my RSocket gateway, my configuration to talk to the external thing. It's going to take the greetings request, it's going to send it to the outbound RSocket endpoint, it's going to get back a stream of responses. So technically, at the next level, the next thing I can do here is handle the data. Well, what I'm getting back is actually a reactive stream of greetings responses, right? Well, that's actually a publisher. I don't want just a publisher. I want the individual constituent greetings responses, not the aggregate that contains all the types, right? So instead of doing that, what I'm going to do is I'm going to split the data. I'll say apply a split. Now this is a split operation. It would normally work with things like correlation keys, and I've got a message which is part 1 of 10 or whatever, or whatever. You'd use a split for that kind of thing. But Spring Integration's split operator also knows about reactive API. So it knows what to do if you say, hey, I've got a payload that is itself a publisher, please split it. It's going to unpack each constituent message and then emit those to you to handle. The thing, of course, is what do you want to do when you're downstream of a reactive stream? What do you want to do when you're the thing consuming the data that's being emitted from a reactive stream? Well, you might want to apply back pressure, right? And so we want to introduce a back pressure aware component. Now, in Spring Integration, as with most messaging technologies, you've got this concept of a message channel. A message channel is a thing through which messages flow. A message channel is an explicit pattern in that book I just described to you. It's a way to logically describe how data goes from one component to another. By default, our message channel in Spring Integration is more or less a Java util queue. But what I'm doing is I'm using the Flux Builder DSL to give myself a back pressure aware message channel. Okay, and then what that's going to do is it's going to conduct the data through the back pressure aware message channel, which can communicate back pressure if it needs to. And then finally, I'll do a generic handler to work with each individual response. How convenient, huh? So .get, and I'm going to print out the data. I'm going to just print it out. Each record that comes back, I'll just print out the new, not split, I'm not sure what that means. Okay, say this there, and headers is just a map. So key and value. Okay, system out, header, key equals value. Okay, so there's my entire Spring integration pipeline. But again, all I'm doing is I'm taking data in, I'm processing the data, I'm sending the message into a channel, and then on the other end of the channel, after the data comes out of the channel, I'm handling it. But I could have, again, you can see anything you would have put, I put an RSocket gateway. There's no reason that here in the handle method, you couldn't then send the message instead to a Kafka queue or something like that, or a file system, or an email server, or Twitter, or whatever, anything that Spring Integration knows how to talk to, right? MQTT, etc. So it's a very nice way to integrate disparate systems. And again, this is a very natural way to think about the world, is in terms of asynchronous message style semantics, right? Pipes and filters architectures. Did I start this? I did. Good. So now this is not going to work until we kick off the pipeline, right? So desktop in, there's nothing in it, right? I have to hello cjug 2020 hello, right? And as soon as I do that, you can see on the left, on the bottom here, it's printing out a new greeting every second. Hello, CJoke 2020, forever and ever and ever. And you can see all the headers associated with each message, right? So that's how you write a reactive integration application. Now, this is one kind of client to your RSocket service, but it is by no means the only kind, right? So what we're going to do is now go back and look at a sort of RSocket only approach, right? We're going to go ahead and build RSocket. We're going to use security again. And here, I'm just going to call this client, and I'll hit generate. You can see I'm good with names. I'm good with names. I got it from my dad. My dad had a little white poodle, and the little white poodle was our family dog for almost a decade, and his name was White Dog. Yeah, it wasn't good. My dad was not great with names. And then my mom always jokes. I'm not sure if she was joking. I would like to believe she was joking. That I'm lucky that my dad didn't name me, because what do you think he would have named me, right? So, client application. Now, here we're going to be a client to our RSocket endpoint. The easiest way to do this is to use the RSocket requester type. Now, the RSocket requester is like the reactive web client. It's a thing that you can use to set up a call and then make a call to the downstream service. The thing is that's different is that you will connect on first starting up the application, right? So you're actually, I'm done. I've already done everything I'm going to need to do to talk to that service now, right? I will never have to do anything else because I don't have to connect again beyond that first time. Now, there is support for retrying the request if something should fail. That's part one. And also a really interesting avenue, which is not yet quite GA, which is why I'm not showing it to you. Another interesting opportunity is the RSocket broker. So if you look at, I told you about the Reactive Foundation on which the Spring team and Alibaba and Facebook and others are contributors, and Lightbend and so on. All of us, all these different teams, all these different people are building a proxy, a hub, a broker. And so imagine this. Imagine you've got an RSocket service sat in your architecture somewhere, and it acts as a place to which RSocket clients connect. They stay connected to the hub, and the hub is also aware, because of the backpressure awareness that we talked about before, of any services that are available to respond to the request. So imagine it's got open sockets that are being maintained, talking to 10 different instances of the service, right? Well, if one of them is down, it can say, oh, you're too busy, too high, I'm going to move to this other node. And so it can automatically do load balancing for us, right? So you can actually have this RSocket thing, this RSocket requester, connect to a host and port for a gateway node instead of just a local node like I'm doing right now. That could be a parameter. You could easily swap that out, right? So what I'm going to do is I'm going to say, okay, when the application starts up, RSocket requester listener, or whatever. Let's just do that, okay? So return event and RSocket requester. Okay, here's my RSocket requester. What I'm going to do is I'm going to say requester.route greetings data, and the data that we're going to send, of course, is the greetings request, just as before. So copy and paste our DTOs there. Okay. And here, I'll say new greetings request. The data I'm going to send in is going to be CJUG client, so we know it's coming from the client, right? And then we're going to expect a stream of responses. So here is how we tell the service what kind of interaction we're expecting, right? If I had said that I'm retrieving a mono and the type was void.class, that would be fire and forget, right? In fact, if I want a synonym for retrieve mono of void.class is actually called send. So that gives you the same thing. So I'm actually expecting a response back of type greetings response, etc. Okay. Somebody just asked. There's no code generation. Exactly. There's no code generation with this. I mean, you can do it, I guess, but why? You know? Okay. So route data retrieve response. Okay, and then I'm going to say I want to subscribe. Okay, so I'm just going to print out the results. Print line. Voila. Okay. So there's my my basic RSocket requester interaction. Let's run this and see what we get. I'll drink some more coffee. I think I've earned it. Rookie mistake, my friends. You know what I just did? The client is an RSocket client, but it's not a service yet. So there's nothing keeping it bound to a particular port. And so it started, it said, well, there's nothing to do here, and it stopped. So I need to keep the process running. One way to do that is just to wait for the next character, I suppose. Get C. Okay, there we go. So now I'm getting my CJUG response, CJUG client response every second, right, in perpetuity, forever and ever and ever. That's a very simple example. Now, this isn't so bad. I'll be the first to say it. This is really easy, right? But sometimes people want automatically generated clients. Maybe easy to understand clients, right? Maybe they don't want to have to rewrite the client connectivity logic. And in fact, if you've ever used our Spring Cloud Feign support, which integrated Netflix's Open Feign project, well, it's no longer Netflix's, it's now an open source thing, but it started at Netflix. Then you know the idea. You have an interface, you annotate it with a mapping for the HTTP request, and it'll generate a client for you, right? And that's pretty convenient. Now, some people will say, well, why would you want to do that? HTTP is actually a messaging technology, and it has hypermedia, so you should never try and emulate RPC semantics with HTTP, to which I say, fair point, but for RSocket, there's really no such objection, right? You can actually just use it. Thanks. Now, I don't know if you can see from there, the buildings, but we're 12 floors off the ground. It's a long drop. I don't understand how that sound just bounces right into my eardrums. I trust you all heard that motorcycle being a nuisance. Okay, so some people say they want, oh, what? Did you hear it?
No, I thought I heard some funny sound, but that was a motorcycle? Okay.
Yeah, it was an exhauster. Yeah, it's crazy. I can't believe how, and for some reason, we've recently been, there's been a spate of like muscle car enthusiasts that just insist on revving their engines into all hours of the morning. I live in downtown San Francisco, kind of like right in the middle of Soma, and I think because of the pandemic, because there's nobody here, right? Like there's nobody coming to the office, right? So these insert epithet here, these people seem to be just keen on doing drag racing down the street, and it's just really annoying. It's like muscle cars. I don't mind if they race because, well, I mean, I do, I suppose. It's safe. It's a safety hazard, but it's the noise. Oh my goodness. They'll do it until 2 a.m. It's nonsensical. Anywho, forgive me. That was a diatribe. So what I'm saying is, an RPC-like client can be very useful. So, Spring Projects Experimental. Okay. GitHub. Okay. Where does this go? Choose another folder. I gotta remember to keep this available. All right, good. So there's this new project that I created called Spring RetroSocket, and its use is pretty straightforward. The idea is you go to the documentation. It's not yet GA, mind you, super not GA. In fact, it's experimental. It may never be GA without you. It's kind of like Peter Pan. You have to believe in order for it to be real, right? So you go add the dependencies, and there you go, get that. And then you have to make sure you're using the milestone repositories because it's not yet GA, right? It's still early days yet. It's not in the Maven Central repositories. And then with that done, you can actually just build a declarative client. So you go down here and you say, first you go up here and you say, I want to enable RSocket clients, thank you. And you say down here, I want to build an RSocket client called interface greeting client, flux of greetings response, greetings request, message mapping, greetings. Okay, so RSocket client, and then there's my interface, and that's it. That's the entire sum of what I need to do to make that work. So let's take this. We're going to call this RetroSocket greetings client, and here a lot of that just becomes much easier, right? So now I can give people the name, greetings request. What is the request? Greetings request. CDUG. Come on, keyboard. Okay, there we go. CDUG RetroSocket. Somebody just said they prefer to have code generation. Cannot imagine why, but you can do that if you want. I mean, just seems sort of not great. So here's the client. Yeah, see client.greet, and I get the response back, and I can stream it out. So so we don't have dueling banjos here. I'm going to comment out the other one so we don't see constant data interleaving. Okay. There you go. Same response, same thing. Okay. Alrighty. So there you go. There's our response. Good stuff. Now we have two clients, and we've looked at RSC. We looked at Spring integration. We looked at the RSocket requester. We looked at RetroSocket. All this time we've been acting as a client to the downstream service. Okay, and this is basically request. We make a request and we get a response. One of the most powerful aspects of this API is that you can actually do bi-directional communication. So what I can do is I can actually create an endpoint as a client that the service can ask questions of. Right? So once we're connected, I want the service to be able to ask me as a client questions about what's happening. So I'm going to create just a fake endpoint here called a client health controller, okay? And it'll just be a Boolean. It'll just be a private funnel Boolean healthy. It's going to be a stream of that information, okay? So it'll be public flex of client health state and health. Message mapping, health, return, and here what I'm going to do is I'm going to return an infinite stream just as before. Okay. Oh, we want there you go. That's that one. We want to say okay, flex.fromStream stream.generate new supplier, and we'll say return new client health state, and the Boolean that we're going to pass in is going to be random, surely. So it'll be true if the math.random is greater than 0.2. So basically we have an 80, well, now we have an 80% chance of the service being healthy. But after that, it might not be healthy, right? And if it's not healthy, we want the service to stop sending data. So we're going to say, hey, as a client, here's my ongoing heartbeat, okay? And as long as the heartbeat says healthy, great. But if it doesn't say healthy, then we want the service to stop sending data, or the service rather would like to not send data because it doesn't want to waste its time, right? So I want my client to make that endpoint available. And so we can do this by having an RSocket connector. So I'm going to say config acceptor, and here I need to provide a bean of type socket acceptor, and I'll say I need the RSocket strategies again. Notice that that's a thing, right? And the socket acceptor I can build by using the RSocket message handler .responder strategies, and then of course I'm going to provide the reference to the controller itself. So there's this. Good. Okay, there's my socket acceptor. So I'm going to inject this bit here. Socket acceptor. There you go. There's my socket acceptor. So with that, now when somebody connects to this endpoint, they can ask the client questions. They can say, hey, what's your health? And it'll get back a stream. And let me reread this code to make sure I got it right. So if this is greater than 0.2 and it's from 0 to 1.0, which is to say it's got an 80% chance of it being greater, then it's healthy. In the rare, hopefully rare chance that it's, you know what, make it 90%. There you go. And the hopefully rare 10% chance that it's not healthy, it'll be Boolean false, right? So that's our client. Now, before we start the client up, let's rebuild the service to take advantage of that information. So what I want to do here is I want to say, okay, var replies, or greetings, right? That's my stream of greetings. And this is the controller that's going to intercept the incoming request. When the request comes in, I can ask Spring to give us a pointer to the client's socket, right? I can actually just inject it there. And I want to get a pointer to the health. So I'm going to actually copy and paste this type as my DTO as well. And here, I'm going to say, okay, client socket dot route health retrieve flux of type client health state. Right? So this is a stream of client health state, and this is a stream of greetings response. So what I want to say is send back a response only as long as this is true. So what I'm going to do is I'm going to filter this. It'll say CHS is healthy. Right? So filter is going to take every single record that we see. It's going to drop any of them that are healthy. So if it's not healthy, it'll keep them. If it is healthy, it'll discard them, because we don't care if it's healthy. We care only when it's not healthy. That's when things have to change. So we're going to say filter and keep only the records that we see, only the records that get emitted from the client that are not healthy. And now we can use some of the amazing operators in Reactor to say, okay, given the greetings, I want to take data from the greeting stream only so long as there's health. As long as the health, only so long as the health stream is empty. As soon as there's one item in it, that means that something is not healthy, and therefore we should stop sending back the greetings, right? So a very, very convenient kind of thing to do, to say, do this only while this is true, right? Okay, so there's our service. Let's restart the service. Did I restart it already? That was quick. Oh no. Sometimes, friends, you see that little skeleton there? I can't zoom in because it's the pandemic and zooming in doesn't work unless you're streaming, but it's stuck. Sometimes this gets stuck out of process. You have to actually go there and take it out manually. So it's going to restart, but whilst it's doing that, let me just make sure that nothing is running astray. So Josh bin kill Java, okay. PS grab Java. There you go. Good. So let's restart the service, and then the client will start up in a second here. So what we should see is some amount of data being requested, and then it very quickly stopping. Oh, that was a little too quick. That's a bummer. Okay, we got one response, right? And then we got an unhealthy health state from the client, and so the service stops sending us data. Okay, so there you go. Very simple example. Let's there you go. It's just a very simple example. Now that's bi-directional communication. Now the last thing I want to do before we wind up for our evening together is to take a look at using security. Right. So I've got an RSocket client and an RSocket service. We can use Spring Security here. Spring Security allows you to have one node, protect itself against any kind of incoming request. And so what we're going to do is we're going to go back to the build, bring in these 3 bits, these 3 dependencies, paste, get rid of all that, and shift R. Okay, and I'll say, okay, this is a security configuration. And we're not going to spend too much time reintroducing Spring Security, but suffice it to say it answers 2 questions, which is authentication and authorization. So return new map reactive user details. And the first question, of course, is who can who can access the service? What can, who's allowed in, right? That's, or rather, who is making the request? That's the question that that authentication answers, right? I'm answering the question, is this Josh? Is it Mary? Who is it? Who's making this request? The second question that we can answer with Spring Security is that of authorization. That is to say, once we know who it is, what are they allowed to do? Is it a read-only view? Is it admin level privileges? Is it just regular read and write for sensible defaults? I mean, what data do you have access to? What can you do once you're inside the system? That is the question of authorization. So what I'm going to do is configure authorization by configuring an RSocket filter, basically, right? So I say security dot, I'm going to use simple authentication, which is a bit akin to HTTP basic. I could, by the by, use JWT, but I don't need that right now, so I'll just use simple. And I will then use, I think that's it. Oh, and I will also lock down certain, I can customize which routes. I can say, okay, this route, whatever, and you can use wildcard and things like that, is permit all, right? I can do that kind of stuff. But for our purposes, just to keep it simple, I'll say anything at all has to be authenticated, okay? So once I've done that, it's already locked down, right? Actually, and what I've just done really is just basically slightly more involved than what I would have gotten had I left the Spring Boot starter dependencies on the class path by default. That's what I would have gotten before anyway, except now I have a way to authenticate because I've described a user. The last thing I want to do is I want to make it so that I can change this code a little bit, right? What I really want to do is when the request comes in, I don't actually care about the greetings request. What I care about is the current authenticated user that's represented by the current request. Because I'm going to use that user to get their username to then provide a stream of responses. So it should, if we do it correctly, it should say hello day long, right? Or whatever. So let's refactor the code just a bit here. And I'm going to inject an authenticated principal of type user details, user. Okay. So here, I'll say return user dot map ud dot get username, and I'm going to map that user to a new greetings request, and I'm going to flat map that by calling the original method. So I'll say gr is going to be u. Okay, and then I'll say call greet. Okay, client RSocket and user. Good. Now that's my refactored code. So I'm now telling Spring to inject the current current transaction, the current request, the current in-flight request is being made on behalf of who, right? So I'm gonna do that here. That's going to be the current user. So that's, in order for this to work though, I need to do one more thing. In order for this annotation to mean anything in Spring Security, we have to actually enable that one last bit. So the way you do that is with a RSocket message handler. I think it's like this, RSocket message handler. No, what is that? And, is that right? Yeah, okay, so say M new RSocket message handler. Save that to a variable var Okay, set RSocket strategies, good. Strategies, RSocket message handler.get, okay. And then add a new simple authenticator principal argument resolver. So that's all we're doing is we're adding that argument resolver. There you go. That's why that thing was so unhappy to help me with my auto completion. What's that about? Okay, so we've got all that done. And all that's going to do is it's going to enable the authenticated principal annotation. So once that's done, we have our service. Now we can revisit our client, and we just need to teach it to speak security to the service. Now, the way that we conduct security information, tokens, things like that, is through headers. In the RSocket world, those headers are called metadata. And metadata is not a usual key value pair. It's actually a MIME type mapped to a value, because you need the MIME type to teach the framework, whatever framework it is, be it a Go framework or a JavaScript framework or Java or whatever, how to unpack that header. There's no, because again, we don't prescribe how you should encode data, so it is up for grabs, right? So we're going to create a credential, right? Credential, new username, password, Jong, PW, and of course you should never hard code your usernames and passwords. This is a terrible idea, absolutely terrible, but it's a good demo. Okay, so MIME type utils.parse whatever well-known MIME type dot blah. Okay, so there's my credential, there's my username and metadata, my credential and my MIME type, and I need to send this data at one of two places or both places. When the socket connection is first established, I can send it then, but again, that only happens one time. That happens at the very beginning of the application lifecycle, or I need to send it per transaction, right? And so let's look at both of those opportunities here. If I did that here, I could say set up metadata, credentials, this.MIME type, okay, very good. Or I could do it per transaction here, and I say metadata, this dot credentials, this dot MIME type. Did I do it the wrong way around? Maybe it goes down one level. There you go. So either way, it's fine, right? It depends on whether you want to authenticate once per connected JVMs or per each user transaction. So each user might have their own credential, obviously, and so you might want to, it's a multiplex socket, a multiplex stream. The only other thing that we're going to be missing here, and is because it's MIME type, something needs to process that security information, right? Again, the security mechanism is not built into RSocket. It's extensible, just like HTTP. So we need to customize it, and we do that by creating a new customizer. So new, and a customization that we're going to do is to provide a new simple authentication encoder. Okay, and that's it. That's the entire thing. So let's run this now. If everything goes to plan, it's going to completely ignore CJUG client. Right? It doesn't care about that anymore. What did I do? Connection refused. Oh, this is stuck on the port again, my friends. I forgot to. It never restarted. No wonder it's not. It's not working. Okay, start again on the client service. Now let's start the client. What did I do now? Oops, something is wrong. Oh wait, did I recursive did. My goodness, silly me. Okay, so we want to send in that. Okay, service is up. Restart the client. Here we are, my friends. We only got one in this case. Again, seems to have hit that number, but you can see what's happening. We're able to greet the JLongs, not the CJUG client. It's taking advantage. It's aware of the current authenticated user, not the data that we send in. You could send in data still, by the way. I'm just not using that to inform the response. That's all. Like I could actually still get access to the greetings request if I wanted to. I could print it out, right? So, my friends, we've covered a lot, and yet we've only begun. We've only begun to scratch the surface. I hope you got something out of this. It's been a fun ride for me. I hope it was for you. Though we only got to look at just the basic stuff so far, I really hope you see the opportunity here. RSocket's going to be big one day. You just take my words for it. I spend a lot of time. No, I used to. That's a past tense thing. I used to spend time on planes, and when I used to spend time on planes, I'd go to organizations, large and small. I'd talk to them about this, that, and the rest, and constantly the question was, well, how do we do something like gRPC, right? And it's like, well, it's not quite what we want for people in our community, you know. And it wasn't reactive. It was code generation, and it's Google Protocol Bus, all the things that take away control, right? Like I want more control and more flexibility with less work. And so I was just so happy to be able to finally be able to talk about RSocket 2 years ago when we committed in Spring 1 2018 to supporting it, and we formally joined the effort there. And I'm just so happy that now it's pervasive. It's everywhere in the Spring ecosystem. It's got Spring Data, Spring Security, Spring Boot, Spring Framework itself. You saw that Spring Framework, Spring Integration, Spring Batch, everywhere. Spring Cloud is it's a very interesting technology, and it's growing by leaps and bounds. And it's owing in part, of course, to the open reactive community, right? So Mary, of course, is a very prolific speaker about all things reactive. So she and I could write code that could talk to each other in terms of these reactive APIs, no problem, right? That's the benefit of this. And so that's why it's such a nice place for all of us in the community right now. The folks from Lightbend and from IBM and from all these amazing organizations can get together and build these really, really resource efficient, really, really sort of robust, failure resistant services and systems. And it just works. So it's a wonderful place, and I hope you'll consider it, and let me know if there's anything I can do to help you on your journey to production. And Mary, thank you so much for having me today, and everybody else. I hope you got something out of it.
Thank you, Josh. I always enjoy watching you. You're amazing, like magician on the, and I'm learning so much from you too. I'm like, wow, you're amazing. It's like magic.
Thanks, you, my friend.
Thank you. Let me see if anybody has some questions. Or did we or Josh, did you address some of those questions that we saw?
I only addressed one of them. I only addressed one, which is that somebody wanted like code generation, and I was like, well.
Rakesh, right? Yeah. Rakesh, feel free to unmute yourself and ask questions too.
I saw something pop up.
That's right. Rakesh? Are you still here, Rakesh? Maybe he.
Hey, Mary. Yeah, I'm online. Yeah. Hey, Josh.
Great.
Yeah, nice presentation. So, without code generation, how do you share all those domains or DTO objects? It's because you are doing a copy paste, but in a big company, how do you actually do a copy paste of all the DTOs and domain objects? You would need a library, and you would need to share, right? Then that will be a problem. So let's say you have 10 teams, you have 10 domain libraries. Then if you have dependencies between those teams, that would be a mess. I would rather have an open API spec or use the gRPC protobufs buffs to generate it. That is my opinion. That is one question I had. Yeah.
Sure. I guess you're entitled to that. I don't see what that buys you in terms of complexity. Now everybody has to generate their own client as opposed to just having one client, put it away. Just because there's an open protocol for MySQL, I don't think it's fair to ask every user to generate their own driver for MySQL, right? Just use the client. If you're worried about version management and so on, then, there's definitely, one thing I would love to see is Spring Cloud contract support for RSocket so that we can actually have consumer-driven contract testing and consumer-driven contract verification for potentially incompatible payloads sent across the wire. But either way, I don't see how what you're proposing is any less error-prone or complex than just sharing a library, which at least avoids the step of having to make every team build their own client. But maybe missing something. And either way, it wouldn't be hard to, you saw I just did it with Spring. I created this RetroSocket thing. So a meta signature, you could literally look at one interface and generate whatever code you wanted from that. My client, right, RetroSocket client here, well, you can't see my client, but because I'm not showing my screen, but that the signature there is, it's a flux of T that gets returned from a method that takes a single value in or whatever. So you can very easily, there's only 4 interaction models, right? So you can suss out the signature of the method what that would do, right? What that would map to, if it's a
I see.
model. Yeah.
Yeah. Thank you, Josh. So I have another question, and then I'll be done for today. So, what are your thoughts on server-sent events? Did you
Sure.
have you seen?
So server-side events is a JSON protocol where you send data. You send data colon space and then the JSON payload and then a new line and a new line, right? It's a HTTP content type that you can easily do with Spring Web Flux, right? You just create a git mapping and return a flux. If you return a flux, and it'll give you server-side events. Server-side events are even less powerful than WebSockets, and WebSockets are even less powerful than RSocket. So, but if you can't do WebSockets and you can't do RSocket, then that's fine. And there's even an object in JavaScript. So in JavaScript you have the WebSocket object, but there's also there's a Java object like the WebSocket object for server-side events, and so it's nice. It has an API. It's like on message equals handle the message and so on.
Thank you.
Sure. Cheers.
Great.
I did Spring Tips videos on that, by the way. There's a Spring Tip video showing server-side events and reactive APIs and so on. Or you can use, if you're not on reactive, you can use the old SSE emitter from Spring MVC servlet. By the way, everything I've showed you is in tandem with Spring MVC. I mean to imply that we're dropping support for servlets or anything like that. We expect that that's going to be around for a good long time. But for your new stuff, my friends, or even for the stuff over which you have some latitude of freedom and you can rework it a little bit, I encourage you to investigate Reactive, and I encourage you to investigate something like RSocket.
Yep. Great.
Let's see. There are some other questions here.
Arvin. Arvin.
Oh, sorry.
How is different from pagination with retry?
Yeah. Hi, Josh. Hi, Josh. I really like your Spring Conf video, and thanks for today's thing. So my main question was one of the things that you said was there's an edge device, and let's say it's going in a tunnel, and it forgot, it didn't get some data. So it's almost like the client knows what it did not receive. So therefore it will ask, okay, I want from this position, this place. So I was kind of confused that when you said, how would the server know what the client did not get? So that was a little confusing. That's why I was isn't it similar to pagination with a retry that a client is technically asking?
It's just less. RSocket keeps that. I don't know how the RSocket protocol does that, but it does. It's in the message protocol. I don't know the details though. But yeah, it's very similar. It's just less work for us to do. That's all.
Okay, I had one thing more to ask you. Is so there's this unique problem statement where I'm trying to use RSocket for. It's I have a front-end app and I want it slowly to load with more data rather than having one huge bundle of data or resources combining and then sending it to the front end. So one part I didn't quite get is can it be a single socket endpoint which is custom to every front-end user maybe, or edge device, more like that? So I have a greetings endpoint as you had, but it's a little different based on the payload that I'm kind of aggregating. That's correct.
So you want the greeting response to be different for each user?
Yes.
So I did that with it, but I sent in greetings request. And the response was different, right?
Yes, but that was you're redirecting it to another controller endpoint. Am I right to assume that?
No, sorry. I moved too quickly. All I did was I redirected it to. I just invoked a method. I got rid of the annotation, so it was no longer a controller endpoint. Where's the share button here? Sorry about that, friend. I went too quickly on that, and I shouldn't have done that. So here's the service, and this is just a regular method now. That's all. See what I see. I didn't want to rewrite this. That's all. I'm just lazy. I could have just put that in here.
Okay.
Refactor. inline method. There, exact same thing. Now I've just got one controller method.
I see. I think this makes a little bit more sense to me, but I have to go through it again. Let me be honest. It's a lot of material today. Yeah. Thanks a lot.
Sorry to drop so much on you. That's why I always start off the presentation with a discussion of where to get the code. As always, it's github.com, Josh Long, RSocket Revolution. There you go.
Got it.
And this video has been recorded, I think, right, Mary? So
That's correct.
hopefully,
Yep.
you know,
Yes.
if you want to slow it down,
Yeah,
Definitely. I mean, I always listen to most of your videos once or twice, but it does make a lot of sense the second time. So
oh,
thanks again.
thank you very much for that, by the way. I appreciate that.
Yep.
Thank you. Thank you. Thank you for all your questions, and thank you again for Josh. And